Last week, I coded my miniature bioreactor for the first time, and it was awesome to start getting into the intersection of biology and coding. And this week, I've written up some more advanced programs to do some more advanced things with the Pioreactor, and I'm going to show you how they work right now. Hey, I'm Olian, and I'm once again experimenting with microalgae. Last week, I gave you guys an introduction to the Pioreactor, and I built a pretty simple program, a day-night cycle for the algae. But this week, I moved on to some harder stuff, and I built a program that allows us to change the light intensity as the algae grow. Here's why that's important. When I start off the algae culture, they're at a pretty low number of cells per milliliter. That is, the number of algae that is in a milliliter of water. And that means that the light they receive should also be pretty low, because there's very few cells. But as the algae grow, they replicate and they divide, and that means that there are more cells per milliliter every day. And correspondingly, it would be good if the light intensity could increase, so that every cell within the algae culture is getting the same amount of light consistently. That would really help them grow because they would never run out of light. Now this is enabled by two features of the Pioreactor. The first is that the Pioreactor is constantly monitoring optical density. Optical density is a measure of how much light the algae culture is absorbing. And it's directly related to that cells per milliliter that I was talking about. So as we measure optical density, and as optical density grows up, we can see how the algae are growing. Now the other thing the Pioreactor lets us do is control the light intensity of the culture. So the light intensity is essentially how much light is being pushed into the algae at a time, and it's directly controllable using the LED feature on the Pioreactor. So it's very possible to create a program that tracks optical density, and as the optical density is monitored to grow up, the light intensity will correspondingly increase. And that's what I've done this week. So this is the code that I wrote. It's basically broken down into 6 parts. And each part has a specific function that I'll go through right now. So, the first bit of this code essentially just imports the Pioreactor's libraries, the commands that you need to control the Pioreactor from afar. And then, I open up the light automation section, which is essentially where we declare the automation name, right here, and the settings that the automation is able to control. So in this case, the duration, which I'll come back to in a second, and the light intensity that I was talking about. Then, I set up a section that basically declares which parameters I want to be able to modify the Pioreactor. So I've noted things like whether the light is active, the channels that the light is inputted into, which is directly on the Pioreactor interface, the light intensity, and the normalized optical density, that optical density that I was talking about before. Then I have the execute section. Essentially what the execute function does is it executes all the code that I want to run at a specific time interval. And that's what that duration is over here. So when I run the code on the Pioreactor, I'll specify the duration, and every duration minutes, the execute code runs. So I can set it to 20 minutes, 20 seconds, 20 hours, all that is possible with the duration function. And essentially what this execute does is it records the normalized optical density, it records the light intensity, and then it runs a program called trigger LEDs, which is right over here. Trigger LEDs is the core part of this program. It takes in the optical density and the light intensity and updates the light intensity according to that optical density. So, and that's reflected right here in this first line. New intensity is equal to optical density times light intensity. OD just stands for optical density. Now what's happening here is that as the OD, normalized OD, increases or decreases, it gets multiplied by the light intensity. And the light intensity will therefore scale with the normalized optical density. And that creates the effect that we want. As optical density goes up, light intensity will also go up. Then it prints the new intensity so we know what's going on, and then it sets the new intensity using the set LED intensity function, which is right over here. This set light intensity function actually does the setting of the light intensity. It takes every channel on the Pioreactor, there's 2 of them for the lights, and updates their light intensity to match the new intensity that we calculated in the trigger LEDs function. So that's the whole program. We go from importing the Pioreactor's commands, then setting up the settings that we want to be able to control, noting down all the parameters from the Pioreactor that we want to monitor and control, then setting up the execute function, which uses the trigger LEDs function to calculate the new optical density and the new light intensity, and then the set LED light intensity function, which actually updates our LEDs. And that's the whole program. So, I've opened up the Pioreactor's command shell, and that's where I'm going to be able to run my program. So I've already uploaded the program to the Pioreactor's files, and I can just straight away type in this, running the LED control, the automation, the light automation, a duration of 0.1, so about 6 seconds, just so I can test some stuff, and a light intensity initially of 5. And I'm going to hit enter on that, and it's running. Now, obviously there won't be an immediate change in the light intensity, because the algae just don't grow that fast. The optical density isn't increasing at a super fast rate. But over the next week, I'll be able to grow the algae, run this automation, and essentially change the light intensity as they grow. And hopefully, that'll lead to a higher growth rate and faster algae growth, which would be really cool. So I'll have more results on that next week after the algae are all done growing. So if you want to see those, make sure to stick around until next week, and make sure to subscribe on YouTube, follow on LinkedIn, and I'll see you in the next one.